Hello everyone. Let's begin with something you've all noticed in daily life. Why does a heavy iron ship float while a tiny stone sinks? Strange, right? To answer this, we must explore the forces acting on a body immersed in a liquid. When a body is placed in a liquid, two forces act on it. First, the weight W of the body, which always acts vertically downward through the center of gravity, trying to sink the body. Second, the upthrust or buoyant force Fb, which acts vertically upward through the center of buoyancy, trying to make the body float. So, flotation is simply the tug-of-war between W and Fb. The winner decides whether the body sinks or floats. Now, let's quantify these forces. The weight W of a body is given by volume into density into acceleration due to gravity. W equals V into rho into G. Equation 1. The upthrust Fb depends on how much liquid gets displaced. It equals the volume of the submerged part of the body into density of liquid into G. Equation 2. So if you know the body's density and how much of it is submerged, you can predict whether it will float or sink. This is the heart of flotation. Let's look at the first case. Suppose the weight of the body is greater than the buoyant force or W greater than Fb. Here, the body sinks completely in the liquid. Its apparent weight becomes W minus Fb, which is still positive. This happens whenever the body's density is greater than the density of the liquid, that is, rho greater than rho L. For example, if you drop an iron ball in water, it will sink because iron is denser than water. Now, the second case. If the weight of the body exactly equals the buoyant force, W equals Fb. In this condition, the body floats just below the surface of the liquid. Its apparent weight becomes zero because the liquid fully balances its weight. This means the body's density is equal to the liquid's density. Rho equals rho L. Think of an egg in pure water. It neither rises fully nor sinks completely. It hovers in between. That's neutral flotation. Next, the third case. If the weight of the body is less than the buoyant force, W less than Fb, then only part of the body gets submerged. Why? Because the liquid only needs to displace enough volume such that the weight of the displaced liquid equals the body's weight. This is why a wooden log or an iceberg floats with some part above water and the rest below. The density of such bodies is less than the density of the liquid, rho less than rho L. That's why ice, with density about 0.9 grams per cubic centimeter, floats in water. Let's put all these ideas into a compact relation. For a floating body, weight of body equals weight of displaced liquid, equation 3. That means W equals Fb. So, the apparent weight of a floating body is zero. This simple relation is used in designing massive ships and submarines. Despite weighing thousands of tons, ships float because their hollow design ensures that the average density of the ship is less than the density of water. So finally, what is the principle of flotation? According to the principle of flotation, the weight of a floating body is always equal to the weight of the liquid displaced by its submerged part. This principle explains why icebergs float, why life jackets keep us safe, and why ships can carry such heavy loads without sinking. So to wrap up, flotation is a perfect balance of weight and buoyant force. I hope this gives you a clear understanding of why some bodies sink, some float, and some hover in liquid. See you in the next session with another fascinating concept of physics.